Hello, today we're going to learn about BFS, which stands for Breadth First Search. So BFS is widely used in graph theory, and it's used in order to traverse the graph. So let's say we have such kind of graph illustrated in this figure, and we have a start node which is equal to 1. So we have to traverse this given graph using BFS algorithm. So in order to do that, first of all, we have to visit our current node, the start node, which is 1. So after that, we have to look to the all neighbors of given node, which is 2, 3, and 4. And after that, we have to set the start node as a visited. The next unvisited node is 2, and we have to look to the neighbors of 2, which is 5, and set the node 2 as visited. The next unvisited node is 3, and we have to look to the neighbors of that node, which is 6 and 7. And after that, we have to set node number 3 as visited. The next unvisited node is 4. We have to look to the neighbors of 4, which is only 8, and after that, we have to set 4 as visited. In the same manner we do for the rest. So the next unvisited node is 5. We have to look to the neighbor, which is 9, and after that we have to set node number 5 as visited. In the same manner we do for the next unvisited node, which is 6. We have to look to the neighbor, which is 10, and after that we set 6 as visited. The next unvisited node is 7. We just set it as a visited because we don't have any neighbor of the 7. The next unvisited node is 8. In the same manner, we don't have any neighbors for the 8. And the next unvisited is 9 and 10. For 9 and 10, we don't have any neighbors. So we do keep doing this operation once all our nodes will be visited. So let's look how we can implement this algorithm using data structure known as a queue. So initially our queue will be empty, and we have to push to our queue the start node, which is 1. So in each step we have to just look to the frontal element of our queue. We have to pop it out, and then we have to push the neighbors of that node. So let's say we have pushed to our queue the 1. The frontal element of that queue currently is 1. We have to look to the neighbors of 1, which is 2, 3, and 4, and we have to add these elements to our queue. So currently it looks like this. Since we have popped out 1, we just have 2, 3, and 4. Again, we have to look to the frontal element, which is 2, and then we have to add the neighbors of that element. The neighbors of 2 is only 5, so we have to add 5 to our queue. Since we popped out 2, we just have we have 3, 4, and 5. So we have to again pop out 3, the frontal element, and we have to add the neighbors of that element, which is 6 and 7. So we add 6 and 7 to our queue. So currently our queue look like this. We don't have 3 because we have popped it out in our previous step. So we have to look again to the frontal element, and we have to pop it out from the queue. And we have to add the neighbors of that node, which is 8. So 8 will be added to the queue. Again, we have to look to the frontal element, which is 5. We have to add the neighbors of 5, which is 9. So 9 comes to here. Here we don't have 5 because we have deleted it in our previous step. We have to look to the frontal element, which is 6. We have to add the neighbors of the 6, which is 10. So 10 comes to here. Then we have to again look to the frontal element, which is 7. And we have to pop out 7. But for 7 we don't have any neighbors, so it means we have to delete only 7. The next frontal element is 8. We have to pop out 8. For 8 we don't have any neighbors. So after that our node queue will look like this. We have to again pop out 9. And for 9 again we don't have any neighbors. And the next element will be 10. We have to look to the frontal element, which is 10, And again, for 10, we don't have any neighbors. So we have to keep doing this until our queue will not be empty. So at the end, we have traversed all the nodes using BFS algorithm, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.